Hi, I'm Patty Mullen, and I want to show you Buckaroo and auto cleaning and show you how to customize Buckaroo to add your own auto cleaning commands. So Buckaroo is a data table UI for Jupyter notebooks and notebook-like environments. I'm running this in Marimo right now. It allows you to view Pandas data frames and Polar's data frames with summary stats and histograms and all the other things you regularly want there. The other thing you want to be able to do with data frames is clean them. And we do the same cleaning commands over and over again. So you could just memorize a bunch of cleaning commands, or you could build this intelligence into a tool that applies cleaning commands based on heuristics. So Buckaroo does not use LLMs. That makes it fast. So right now, we're going to turn on aggressive cleaning. Let's take a look at this data frame first. First, look at your data. Always look at your data. So we have this column that looks like mostly integers, but we have this B9. And then we have this thing that looks like mostly dates, but we have this 17th month, that doesn't exist. And mostly Booleans, but false and on aren't really Booleans. So Pandas is treating these as objects. Let's turn on aggressive auto cleaning. Now we have integers, date times, and Booleans. And we have the original column. So B_orig, so we can see B9 became 9. We can toggle over to the cleaning detail view, and we can see we're using strip int parse. We're actually going to define strip int parse later in this notebook. We have these other original columns, and then we can go down to conservative. So conservative is using the same set of cleaning commands, but it is more conservatively applying them. Back to main. And now I'm going to show you the low-code UI. The low-code UI is how Buckaroo cleaning strategies generate operations in the low-code UI. So string bool is operating on mostly bool, and it's doing these things. Let's come back to aggressive. And we can preserve strip int parse. Now when we go over to conservative, we still have strip int parse because that's preserved. It's no longer generated from the auto cleaning. Come back here. Now, Buckaroo also generates Python code to do all of these things. So you walk away with a Python function. Don't worry, we're not calling a val in Python. We'll get to that. Let's see, do we have any? We're going to drop this column. So now we've added another command. You click on a column, and you can see the column there, column A, US dates, column B. And where's our drop column? There's our drop. Okay, so that's how it works. Now, let's start writing our own cleaning routines. Say we wanted to just clean that in, that column. So let's strip int and period, and like strip everything that's not int and period. I probably could have come up with a better name for that, but yeah, there we are. Treating it as a string. If it was, I'm not doing the combining here. We strip everything that's not an int or period. So 8675309 becomes 8 million, does not quite roll off the tongue the same. You might not want that all the time, and we're going to get to how you apply which cleaning strategy. But anyway, here we just wrote a function, we've applied it, and we created a data frame. And here we see this is doing the same thing that Buckaroo is doing, but you need to look at this and figure out how to apply it. You look at data frames all the time, and like I've done that, and I've thought, why can't I do a better job? Like, why can't I write a program that does this for me? Well, when you write that program that does it for you, it's going to be really brittle. So you need to be able to change between a bunch of different strategies. So the next step is we write a fraction function. And the fraction function goes back to Buckaroo, and it says, what percentage of this column does this cleaning command work with? And and it returns a number between 0 and 1. Hide that. Um, so strip int parse, if we're not an object or a string, return 0, call the same function on it, get the count of rows that's not null, and then divide that by the length of series. One improvement you can make here is you could say, well, look at how many nulls were there before, and now how many nulls are there afterwards. You're probably going to add more nulls with your cleaning method, and that's fine, but you're getting a number between 1 and 0. So we apply this strip in period frac for fraction on a couple of columns. For column A, we get 0. Column B, we get 0.76. And mostly bool, we get 0.30. It works for a couple, but not all the time. Now, we can pick cleaning methods with heuristics. So there's a lot of boilerplate here that I don't want to go into right now, but basically we're saying here for each column you're going to get the fraction for each one of your cleaning frac function applied, and then you want to choose the best fraction function. So there is heuristic language in Buckaroo, and when you use base heuristic cleaning genops, you extend that. This will pick one of the functions, and we're saying if the fraction is greater than 0.75, use that. Otherwise, return 0. So 0.7, if it's greater than 0.75, return that. Otherwise, return 0. We have none because most of the time you don't want to clean anything. And the cleaning heuristics are going to choose the highest score from all of this. Primary. So for US dates, you're going to want, if you parse as a date at all, that's a pretty good signal. And like you might have more that would parse as a number, but primary just multiplies that by 100, so it's much more likely to be chosen. Now we integrate this into the low-code UI. So the low-code UI is Buckaroo. This is how Buckaroo generates those boxes, and it generates the Python code. You operate in the low-code to add a command to the low-code UI, you have the default way of describing the command, and then you have command pattern. This function basically takes no arguments other than the data frame and column. There are functions that do, and you can specify types, and you get a little editor in the low-code UI. And you have two functions. Transform operates on the data frame. Transform to Py returns Python code that does the equivalent of the transform function. That's how we generated the Python code. And then we put all this together with an auto-cleaning config. In an auto-cleaning config, we're saying conservative AC here. And we're saying take heuristic fracs, which generates all of those fractions. We combined all of those in that function. Your genops function, and give it a name. And you also give it all the command classes. And it's saying, here is a set of the world. So you could actually put in a different implementation of strip int parse here if you wanted to. If you wanted to play with a different implementation, that's something you could do here. And then we put all of this together with my auto cleaning config, and we have no cleaning config, aggressive AC, and this conservative AC, which we just defined. We also added this cleaning detail styling. So let's turn back on aggressive, and I'll show you what that's doing. So this is telling us, I can make this a little bit wider. This can tell us the fraction for each one of the functions, and then which cleaning name, which ends up being which function we applied. That's it. And then if you're still paying attention at this point, I don't know if you noticed this, but strip int parse, you're actually defining a command that runs in JLisp. So the Buckaroo low-code UI is built on top of a JSON flavored Lisp that I wrote, and there is a video and notebook explaining that. Thank you very much for your time. pip install Buckaroo, and just look for Buckaroo on GitHub. Thank you very much.